now going to talk about regression. So a lot of times I usually give you the equation and I want you to find points on that function. Regression is the process when I'm given the points and I want the equation. So not everything in real life follows an exact pattern, right? There's what's called bias. You can have biased data results which cause your function or your points to not make a perfectly shaped function. However, there's this thing called regression, which means there's a general pattern and a general trend to what your points look like, whether they look like a line or they look like a parabola or they look like an absolute value function. These are all examples of regression. So what we're going to do is let's go ahead and let's look at this first example. It says the table below shows the number of alternate fueled cars in the United States after 1997. Make a scatter plot using the data. All right, so I'm going to go ahead and I'm just going to rough estimate this, right? Over 0 up to 80. 0, 200, 250, 280, and it's about like right there. Okay, over 1 up 295. Over 2 up 322. Hopefully you're okay with what I'm doing. Over 3 up 395. Over 4 up 425. And if I'm going too fast, you can obviously pause this video. Over 5 up 471. Over 6 up 511. Over 7 up 548. Okay? So when you make a scatter plot, you don't connect your dots. So you're going to leave it just as is. So if you take a look at this, would you say it's increasing or decreasing? Well, hopefully you'd say it's increasing. And what shape does it seem to make? Well, I think it looks pretty much close to a line. Wouldn't you agree? It makes a linear pattern. And then it says, and about how many alternate fueled cars were there in 2005? So if this is 1997, 98, 99, 2000, 2001, 2002, 2003, 2004. So let's take a guess at what you think if I plugged in an 8 here. So if I went over 8, where it'd have to be somewhere up there, right? Take a guess. What would you think? My guess is going to be somewhere around about 590. Okay? So now it says, draw a line that would best fit this data. So if I connect my dots, I'm making a line that connects as many points as possible, that gets as close as possible to as many points. So that's my line of best fit. So now it says find the line of best fit. How do I do that? Well, I have to use the calculator. So how I use the calculator, let me get out of the screen, and I'm going to press stat, which is right here, and I'm going to press enter. If you have any data in here, so like let me just quickly type in some numbers. If I have any data on my L1 and L2, I'm going to hit the up arrow, I'm going to hit clear, and I'm going to hit the down arrow, and that gets rid of it. If you don't have an L1 or an L2, I need you to turn your calculator around, and there's a little reset button, and I need you to gently put your pencil in the reset button and reset your calculator. So I'm going to type all my X values into L1, and I'm going to type all my Y values into L2. So how I do that, hit 0, enter, 1, enter, 2, enter, and so on and so forth. So I can type all my data in. So I want you to pause this video, and I want you to finish typing your data in, and then unpause when you're done. So if you look at your calculator should look at the exact same as mine. The number one biggest mistake is that you accidentally type something in wrong, or you don't type it in the correct order. So please make sure you double check, because you don't want to get the whole question wrong because you typed something in wrong. So I have all my data in my calculator. I'm now going to press stat. I'm going to go over to calc, and I'm going to go down to number 4 where it says lin reg, because that's linear regression. I can scroll down to 4 and hit enter, or I could just press the number 4. So now it says X list is L1, yes. Y list is L2, yes. My frequently list, that's going to be blank. So now it says store reg EQ. I want to do this. How you do this is you press vars, you go over to y vars, and you hit enter, enter. Okay? So now you're going to scroll down and you're going to hit the word calculate. So notice this is y equals ax plus b, which is the same thing as y equals mx plus b. So I would write y equals, and I'm just going to write it up here, y equals a, and I always round to 3 decimal points with linear regression, 869x plus 262.833. Okay? So that's how I would store it. And that's how I'd write my equation of best fit. Why I did that vars, y vars thing is because if you press y equals, it stores that equation for you. And if I show you just a fun little fact, something you don't really need to know, but if you press second y equals, you get to stat plot. But if you hit enter, and you hit enter to turn it on, and you make sure all this information is correct, so that's a scatter plot, x list is L1, y list is L2, you can pick the color if you want to, and then if you hit zoom 9, it sketches your scatter plot for you. So your scatter plot, there you go, perfect. So now, with part C, if I didn't want to just guess, I wanted to get a more approximate answer, I'm going to take 8 and I'm going to plug it in. So I would do 40.869 times 8 plus 262.833. And if I type all of that into my calculator, let's see, 40.869 times 8 plus 262.833, I get 589.785, which is just about 590. So I guess pretty close. Nice job. So another thing you can do if you don't want to do math, so another fun fact, again, you don't have to know this, but if you want to, if you hit second graph to get your table and you scroll down to 8, notice if you go over, that's your y value, 589.79. It just rounds to 2 decimal places in the calculator. So that's another way to cheat the method if you don't want to show all the work. But if I come down here, the steps that I need to know how to use in my calculator is I'm going to press stat, and then I'm going to press enter, and then I'm going to type in my new data, enter data. And then I'm going to press stat, and then I'm going to press the right arrow over to calc, and then I'm going to press number 4 for linear regression. If you want to store the equation, store reg EQ, the regular equation of best fit, you would press vars, and then you go over to y vars, and then you hit enter times 2. Okay? So, go ahead and let's do this again. If you look at this, I now want you to sketch the scatter plot. So I want you to pause this video. I want you to sketch the scatter plot on your own. And when you finish, unpause and we'll keep going. So hopefully your scatter plot looks something like mine. But if we look at it, it says, is this really more linear or more quadratic? Well, it seems more quadratic. Why? Because of curves. So now it says find the curve of best fit. So, okay, I'm going to go over to my calculator. I'm going to go back to my home screen to show you. I'm going to press stat, enter. I got to clear out all this data. So I'm going to hit the up arrow to my black cursors over L2, clear, down arrow. And then I'm going to do the same thing, clear, down arrow. And I'm going to type all my data in. So pause this video, type your data in. When you finish, unpause. So your data should hopefully look like mine, and hopefully you checked your answers, which I did not, to make sure that you plugged them all in correctly. So then I'm going to press stat. I'm going to go over to calc, but instead of pressing number 4, I want it to be a curve of best fit since it's quadratic. I'm going to press number 5 because that's quad regression. And then I want to go down to store reg EQ, and I'm going to press vars, go over to y vars, and hit enter, enter, and then go down to calculator and hit enter. guys notice it has the standard form of a parabola. So y equals a, which is negative 0.261x squared, plus b, which is 22.591x, plus c, which is 23.029. All right, so let's go ahead and look at it. It says, how far does a pumpkin go at 43 degrees? So if I can look at this table, I'm going to plug 43 in here. So I could plug 43 into all of my x's. But because I did the reg Q, I can do second graph to get my table. And if I can sit here and I can, okay, I can sit here and scroll to 43. This will take forever because this calculator's slower. We can sit here for a few seconds and watch it quickly go. Let's keep going. 10 more. 43. Finding 43. And I get 511.08. So if I were to throw a pumpkin at 43 degrees, it will go 511 feet. I wonder if any of you have ever done this before, because I have not. So let's go ahead and look at the next one. It says, at what angle does the pumpkin travel 520 feet? So if I come over here, I go, okay, 520 feet. My dog's growling at the rain. I'm going to plug that into y. So if I look here and I go 520 equals negative 2.61x squared plus 22.591x plus 23.029. If I had to do it this way, this would take me a very long time to do because I'd have to end up doing the quadratic formula to find it. So if I do the method where I look and I go, okay, I look at my table and I'm going to try to find 520 feet. So I see 510. Well, I see it never gets to 520, right? Because it gets to 511, I think. Now it's like freaking out on me. Gets to 511, but then it goes back down. So at what angle will it be able to go 520 feet? It won't. Which means if I were to solve for x, it would end up being imaginary. All right, and it says, at what angle will the pumpkin travel? Oops, nope, the farthest. At which angle will the pumpkin go the farthest? So when it goes the farthest, that means it's at its maximum height. Max height. So when it's at its maximum height, that means I have to find the vertex. So if you go to your graph and you hit zoom 6, your graph should appear, hopefully. There it is, because we did the y bars. But I gotta find it first. So I'm gonna zoom out and I'm gonna try to find it. Try zooming out one more time and then hopefully I'll be able to see it. Oh boy! This points is because I didn't turn my plot off. But there it is. So I'm gonna hit second trace. And I'm going to do my maximum 4. Go up to my vertex. Go to the left. Hit enter. Go to the right. Hit enter. Hit enter. So my maximum, my vertex is 43.21511.089. So it says at what angle? Angle is represented by x. So that's at 43 degrees. 43 degrees about. Okay, 43.21 degrees if you want to be exact. Again, you didn't have to do that. You could have gone second graph. And you could have said, okay, it goes up to 511 and it goes back down, which means this right here has to be my vertex. Because your vertex is where it changes from increasing to decreasing. So that's 43 degrees as well. So it's whatever method you want to do it. You could have also done it by hand if you wanted to. Okay? So, look at this. What if I don't want to draw a scatter plot to determine if my data is given more linear or more quadratic? So if I look at these pictures, I'll sketch scatter plots to determine that this one looks like a line and this one looks like a parabola. So what if I don't want to do that? If I don't want to do that, I have to use the correlation coefficient, which is called R squared. So I have to use correlation coefficient, which is denoted by R squared. So I can turn R squared on in my calculator by pressing the mode button. And then if you go all the way down and see where it says stat diagnostics, you want to scroll down to turn that on. So I'm going to scroll down to it. I'm going to go over. I'm going to turn it on. This is turned on until you reset your calculator or you turn it off. So you always want to make sure R squared is on. So, and the big thing about R squared is you want it to be close to 1. Must be close to 1. The closer to 1, the stronger it is, the more likely it is that model. So I have my old data still typed in my calculator for my pumpkin throwing example. If I do stat and go over to calc and do number 5 for quad regression, and I just scroll down to calculate, I forget about storing in my regular equation to show you. Notice I now have R squared up here. Notice R squared for this is 0.9927, so that's pretty close to 1. What if I do stat, calc, and instead of 5 for quad reg, I do 4 for lin reg, and I scroll down to calculate. Notice R squared is 0.056, that's not close to 1 at all. Since 0.99 was closer to 1, that means quadratic is a better relationship for this model. Okay? So, looking at these two questions, I want you to try to answer these two questions. What is true about a linear relationship and what is true about a quadratic relationship? When you finish, unpause it and I will go over it. So if I look at this example, it says what is true about a linear relationship? It increases and decreases, right? It increases or decreases at a constant rate, which is what's called your slope. What's true about a quadratic relationship is it increases and then decreases, or vice versa, to be able to get that vertex point. Okay? So you have a problem on the back, and I want you to try this problem on the back. When you finish this problem on the back, you can check my answers on Google Classroom. And then I want you to attempt that problem as well. And again, you can all check it on my Google Classroom, or you can come and ask me, and I'd be happy to go over it.